All right, I'll go through the setup pretty quick here. So we disconnected the main negative to the battery, and from that went through, there's a fuse, inline fuse there, and then we go through a 0.1 ohm shunt, and then that carries on back to the ground. Okay, so that becomes our ground path, is literally just going through a 0.1 ohm shunt. We connect the Pico up to that on one of the channels, so that'd be the red channel there. So we connect the Pico up to that, and it's doing a voltage drop over the shunt, and then the Pico's doing a calculation and changing that into current through a calculation, through an equation. So the red one is measuring current, but it's actually measuring a voltage drop over the shunt. This gives a 100% confidence when there is a draw or when there isn't a draw coming from the vehicle. And it's something that will never power down like a meter. So a meter is a shunt as well, and this is just a shunt that will never power down. We can keep it going. Then channel A, the one up top there, is just simply monitoring battery voltage. And this is telling us lots of good information too. As the parasitic drain turns on, you see that the battery voltage slowly drops down, parasitic drain turns off, current draw decreases, and then you see the battery takes its time recovering back up to where it should be. So the fact that it recovers every time and quite actively tells me the battery's pretty good, right? So the battery is able to chemically recover once the draw has taken place. Keep in mind, this is all living between 12.72 and 12.8. So we're talking very small voltage changes here throughout this. And we've got about 600 milliamp draw coming on for the parasitic drain. Now with that, the green line is simply the Pico amp clamp. And the process here is when you have the battery distribution like that, you end up plugging in the tools, all three circuits, your battery voltage, your shunt current, and then your actual measured current through the current clamp. And the current clamp and the shunt are on the same line during this period. And through that, we verified that we do have an intermittent parasitic drain. Then what you do is you take the current clamp off the shunt line, and I put it on the very first battery connection here for the main power supply, and then we watched it, and you wait. And so you could see that little squiggly in between. That was me disconnecting and reconnecting that amp clamp. And then you see here at the bottom, the amp clamp never showed any current, which means this line here did not have any current going through it when the failure took place. So then we disconnect the amp clamp and we move it to the next one over. And with the next one over, you see that when the failure took, so that was the movement of me moving the clamp there. And then you see once the failure took place, the amp clamp is now registering current again. So this tells me that your intermittent parasitic drain is coming from that. So now you'd have to go to power distribution and just see what is supplied on that line, and then start doing your parasitic drain at that fuse block.